Hello, welcome back. Algorithm here. Today, we'll be solving Leetcode 16, three-sum closest. For this question, I highly recommend that you try solving Leetcode 167 and Leetcode 15, as these two questions will help you tremendously in figuring out the current question. Leetcode 15 is three-sum and Leetcode 167 is two-sum 2. Now, for this question, we're given an array of nums, which has length of n and an integer value that's a target. Our job is to return sum of the three integers, and we can find these three integers in nums such that the sum is closest to the target. Now let's look at the given example. So obviously the naive way would be to iterate the whole array for the three integers, a, b, c, let's call it. Then the naive way would be n cubed. And trust me when I say this, unless it's backtracking or dynamic programming, generally, if your solution is big O of n cubed, you're doing something wrong. So I think it would be idealistic if the solution is between O to the n squared to probably n squared log n or something like that, right? Now, knowing this, what this suggests to me is that we can use sorting algorithms for free because our solution is most likely going to be n squared. And our sorting algorithms are generally n log n, so can sort for free. So I'll just do that for this solution. -4, -1, 1, 2. Now what this allows us to do is to take advantage of the properties of a sorted list. What we'll do is we'll lock in our first integer, which is -4 here, and then we'll treat the rest of the list like a two-sum to figure out a solution, right? Now, since this is sorted, the way we'll solve this question is by having a left and right index at the beginning and the end of the list. So our first option that we're going to iterate through is -4, -1, and 2, which sums up, I guess plus would be better here, to -3. Now our target is 1, so we are 4 apart. Now we want to increase our current sum. And how would we do this? Notice how the list is sorted. Therefore, if we iterate from left to right, it would incrementally increase our current element, right? So we would move our index to the right. We'll try to move the right one, but we obviously can't, right? So we actually move our left index to the one next to it. And this is why I purposely chose our left and right to start at the starting element and the end element. This way, if our current sum is bigger than the target, the only way to decrease would be to move our right index, as our left index cannot move to the left anymore. So this allows us to go to our second iteration, which is -4, 1, 2. Now this will add up to -1. Clearly, this is better than the previous one, as the difference is 2 now. Now, we're still below our target, so we want to increase our current sum, so we move our left index here. But notice how left and right indices are conflicting. This means that we have to break the loop now, because we can't have the same element inside our triplets, right? So we break our iteration and we go to our next iteration when our first integer is set to -1. Now we move our left index and right index here. Notice how we moved it to the next of our first integer and not to -4. This is because notice how this will lead us to have -1, -4, and negative and +2, right? But is this combination already iterated when we had -4 and left, right indices at corresponding positions? That's why we only move our left and right index to the right of our first integer, which is -1 here. So we'll have our left and right index at 1 and 2. Now this will lead to our current sum being 2. Where the difference between the target is 1, which is actually our answer, but we don't know if there will be any other answers. So let's keep iterating through the program. So we're actually above our target, so we want to decrease our current sum. And the way we do it is we move our right index. However, our left and right indices are conflicting, therefore we break out of this loop and we move our first integer to be 1. Or should we? Notice how if we choose 1 here, our left and right index will be conflicting immediately. This is because we need to give enough space for our left and right index to be not conflicting, right? So we know that from observations that we have to iterate to length of n minus 2 or 3, depending on how you're counting. So that's actually the whole solution. Now, obviously, we have to be able to return and compare our targets, but that's very trivial, so I didn't really go in detail. But that's how we solve the question. Now let's get into the code part. So as you remember, we want to sort the list first. And then we're gonna have a dummy result value. So I'll just arbitrarily choose the last 3 indices. So we'll iterate through the first index for letter A, And if you remember, we have to iterate through -2 times because we have to give enough space for left and right index. So we'll have a sum, which will be always include this first, which will always include the A variable, which is the first index. And then we'll set our left and right variable to first index +1 and then n-1 for the end of the list. And we'll iterate through the list using a while loop. Notice how I'm using just less than sign, not less than or equal to, because we can't have it overlapping. And we write toSum equals nums left plus nums right. We update the result variable. So we'll choose if result minus target is bigger than, the absolute value of result minus target is bigger than absolute value of target minus current sum plus 2 sum. I want to use brackets within brackets. If this is the case, we update the result variable. So result equals cur sum plus 2 sum, right? And then now we iterate left and right in this, comparing it to the target. If target is bigger, if target actually equals to current sum plus 2 sum, then we just return 2 sum. And then if target is bigger than current sum plus 2 sum, then we decrement our right index, so right minus 1. Then if the target is bigger than our current sum and plus 2 sum, we want to increase our sum, so we increase our left index. And then if our current sum plus 2 sum is bigger than target, we want to decrease it, so we decrement our right index. And that's it. Return resulting variable. Let me just double check if I made any typos. Oh, it should be length of nums here. I think that's it. Yep, I passed the test cases. Let's see if I passed the, there we go. I have passed.